Hello, good morning to all. This is Khaja Asifullah, lecturer in chemistry from Government Degree College, falaknuma, Hyderabad. Today, I will discuss about the chemistry of complexes, which are also called as coordination compounds. Since this chapter takes more than 2-3 hours, therefore, today's lesson is the first of the series of lessons. Therefore, it is part 1, our first lesson. Before we discuss about the complexes or coordination compounds, let us first take simple salt. What is simple salt? An inorganic salt which contains only one cation and one anion is called a simple salt. There are many salts which are simple salts, like sodium chloride, in which Na plus is sodium cation and Cl minus is chloride ion. Sodium carbonate, in which again sodium is cation, carbonate is anion. Potassium sulfate, potassium cation, sulfate, anion. Aluminium chloride, ammonium bromide, etc. There are many such compounds. These are the examples of simple salts. When these are added to water, or when they are dissolved in water, they will produce only two ions, one cation and one anion. Therefore, these are called simple salt. Then there is another type of salt called as double salt. A salt which contains more than one cation and sometimes more than one anions also. That means it may contain more than two ions in their solid state is called double salt. And when they are added to water, they will produce two cations and one or more anions. They exist only in crystal lattice form and they will lose their identity when dissolved in water. Why? Because inorganic salts or ionic salts have tendency to get ionized in water. Means they will dissociate into their ions in water, forming positive and negative ions or cation and anions. Therefore, they will lose their identity in water. They will exist in double salt forming crystalline structure. These double salts are formed by mixing two saturated compounds. For example, we have few double salts here. First one is called carnallite. Carnallite is an ore of magnesium whose formula is KCl MgCl2 6H2O. Second one, potash alum K2SO4 Al2SO4 24H2O. And then Most salt is also a double salt containing FeSO4, ammonium sulfate NH4 taken twice, so 4, 6H2O. Here all these three are hydrated salts. Therefore, they contain n number of water molecules. Here 6, here 24, again 6 molecules of H2SO4. They have their identity in their crystalline form. When they are added to water, their aqueous solution will contain ions of all these. Means here potassium ion, magnesium ion, and chloride ion in the case of carnallite. And when potassium is added to water, its solution will contain potassium, aluminium, and sulfate ions. So here chloride is common, that is anion is common, but cations are different. Here also the same case. In third case also we have common anion. These cations are different, that is ammonium and ferrous. So their aqueous solution contains 2 cations and 1 anions. In nearly all these 3 examples, we have 2 cations and 1 anion in their aqueous solution. Then comes coordination compounds. What are these coordination compounds? These are also solver complexes. They are also called as complexes. And these are compounds of metals like transition metals having coordinate covalent bonds and which retain their identities even when they are dissolved in water or in any other solvent. Coordination compounds will retain their identity, means either their cation or anion will retain the identity even in its solution with water or with any other solvent. Their properties are completely different from those of constituents. Means once the salt is produced or the complex compound is produced, their properties will be different from the reactants or the compounds from which they are formed. For example, when cobalt chloride is added to ammonia solution, we get a new compound called as cobalt hexamine chloride. Here, this is called coordination compound or complex. Its formula is CONH3 taken 6 times Cl3. This will exist in this form, in crystalline form, whereas in its solution, it will produce 3 chloride ions and the species which is enclosed in a square bracket will remain as a unit. It will not get ionized. So these are 3 negative charges are anions will produce in water, therefore it will have 3 positive charges here. So it is tripositive cation in water. It will give test for cobalt and ammonia. It will give test for chloride ion. Here, this will not give any test for cobalt and ammonia separately. We can test only for chloride. Whereas in a simple salt or in a double salt, what happens when we test? They will give the test for both anions and cations. For example, in Na plus NaCl, it will give you the test for sodium as well as Cl minus, that is chloride. Same is the case with double salt. When carnallite is dissolved in water, it will give test for potassium, magnesium, and chloride. But here it is not the case. Just now, we have taken this example. Cobalt chloride plus ammonia will produce this compound called as complex cobalt hexamine chloride. In water, it will produce these two ions, cation and anion. Here, three anions or three Cl minus ions it will produce. In second case, when we add ferrous cyanide to potassium cyanide, it will produce potassium ferrocyanide. Again, it will produce ions, potassium and this one, ferrocyanide. Here, potassium is cation and this will exist as a unit and it is an anion. So, it will not produce different ions again like ferrous and cyanide. So, they will not be tested separately. Only potassium ion can be tested. Similarly, no separate test can be done for ferrous and cyanide. Okay, why? Because this ion exists as a unit. Now, the ions produced in water like CONH3 taken 6 times with 3 positive charges or FeCN taken 6 times with 4 negative charges are called complex ions. These ions possess coordinate covalent bond. This is the reason why these compounds are called complexes or coordinate covalent compounds. There are few other examples given here, nickel tetracarbonyl, etc., which are the examples of complexes or coordination compounds. Again, they will be having ions like this. These are again complex ions. So what is complex ion? It may be defined as an electrically charged ion, and it may be a cation or an anion. It is an anion, it is a cation. So it may be in cationic form or anionic form or sometimes even a neutral. So a complex ion may exist in neutral form or in cationic form or in anionic form. And it will be formed by the combination of a simple cation from d block elements or transition elements with negative ions or neutral species. These are called ligands. And the metal ion is called central metal ion. And the central metal ion is generally a transition metal ions with positive charge like Ag plus, Ni, CO3 plus, etc. It can also have zero valency like nickel. Here, the valency of nickel is 0, valency of Ag is +1, valency of cobalt is 3+. These central metal ions attach or form bonds with either with the negatively charged ions like Cl minus, Cn minus, Br minus, etc. are with neutral species, like water molecule or ammonia molecule or CO, that is carbonyl group, etc. Here we have certain terms. So we have to learn about the definitions of these terms. First is central metal ion. The central metal ion is generally a cation of transition metal to which one or more molecules or anions are attached. So any metal ion like copper or cobalt or chromium ion or titanium ion, platinum ion, nickel, ferrous, etc. may be there in a complex. It may be either in cationic form or with zero valency, that means neutral. Central metal ion possess empty d orbitals. You have to remember that every central metal ion will possess empty d orbitals. Why? What is the reason? Until and unless the central metal ion has empty d orbitals, it cannot accept one or more electron pairs from the molecules or anions, which are called ligands, to form coordinate covalent bond. So one property that a central metal ion should possess is it should have empty d orbitals so that it can accommodate the incoming or accepted pair of electrons in those empty d orbitals. For example, in the case of ferrous or cobalt, there will be empty d orbitals, and also when they lose one or two or three electrons, few more empty d orbitals will be available to accept the electron pairs from the ligand. This ligand will donate pair of electron, and central metal ion will accept those pair or pairs of electrons. Okay. Therefore, central metal ion is called acceptor. Why? Because it has ability to accept one or more electron pairs. For example, if we consider copper in this case, copper can accept 4 pairs of electrons from ammonia. Here, silver can accept 2 pairs of electrons from cyanide. Platinum can accept 2 electron pairs from ammonia and 4 from chlorine or chloride. Here, cobalt can accept 3 plus 3, 6 pairs of electrons, 3 from ammonia and 3 from NO2. So totally it will be 6 pairs of electrons can accept. Then 6 empty orbitals should be there so that these donate pair of electrons and this can accept pair of electrons during the process of formation of coordinate covalent bond. So what is coordinate covalent bond? Why we are insisting here is when a bond is formed by between two species, such that one species donate one or more pair of electrons, at least one pair of electron to form one bond to the other species, which is ready to accept that pair of electron. Before that, it should possess a vacant orbital. For example, if we take ammonia and boron trifluoride, boron trifluoride is electron deficient species which has an empty or vacant orbital, and ammonia has a pair of electrons on nitrogen, which can donate that pair to boron trifluoride to form a bond. Such type of bond is called coordinate covalent bond, and generally it is represented by an arrow. And here the species which donate electron pair is called donor, and the species which accept a pair of electron is called acceptor. So in that case, ammonia is donor, boron trifluoride is acceptor. So in this way, if a bond is formed, it is called coordinate covalent bond. Here also, in all these compounds or ions, similar situation is there. Here, cobalt is acceptor, and these two are donor of electron pairs, and they will form bonds called as coordinate covalent bond. Here, cobalt can form 3 plus 3, 6 such bonds. Platinum can form 2 plus 4, 6. Nickel can form 4 coordinate covalent bonds. This can form again 4, is forming 2 coordinate covalent bonds. So the complex ion, next is complex ion. It may be defined as an electrically charged ion. It may be either cationic species or anion or an anionic species or even a neutral species, formed by the combination of a simple cation like a metal cation like copper, cobalt, chromium, manganese, or silver, iron, platinum, etc. with a negative ion or a neutral species. Negative ion is anion. And the central metal ion in the complex ion is generally a transition metal ion with positive charge, like silver, Ag plus, cobalt, 3 plus, etc. It can also have a zero valency like nickel. Now, these negative ions, which are either negative or, that means these are the species, either negative ions or neutral ion species attached to metal ions are called ligand. For example, Cl minus, cyanide minus, chloride, cyanide, etc. And neutral molecules like water, ammonia, etc. Now, how a central metal ion is formed? Central metal ion is nothing but any transition metal or D block element which is generally formed in the first stage, in the very first stage, by losing one or more electrons. For example, in the case of cobalt, cobalt atom is losing 3 electrons and forming tripositive cation. This is called central metal atom and this is called central metal ion. Why it is ion? Because it is losing 3 electrons. Now it forms bonds with ligand. Then what is ligand? Ligand is a species, either it is anion or a molecule which donate one or more pair of electrons to form coordinate covalent bonds with the central metal ion. Now, there are different types of ion ligands. Few can donate one electron pair, or few can donate more than one electron pair. That will be discussed in another class. Here, just you please remember, a ligand can donate one electron pair or more than one. For example, all these are having one negative charge, therefore they can donate one electron pair. Ammonia also can donate one electron pair. Here, what happens in NH3 or ammonia, two different elements are there, N and H. H cannot donate electron pair. The electron pair is of nitrogen. In ammonia, nitrogen has a lone pair and it can donate a lone pair. Not the whole molecule, but one atom will be there which can donate the pair of electron to form a coordinate covalent bond with central metal ion. Why? Because it is a donor and central metal ion is acceptor there. Ligand has lone pair of electrons or negative charges, and the property to donate these electron pairs in 1 or 2 or 3 in number. To whom it will donate? To central metal ion to form coordinate covalent bond. Hence, ligand is called donor and central metal ion is called acceptor. Now, next term is coordination number. What is a coordination number? It can be defined as the total number of ligand molecules or number of ions that are attached to the central metal ion, or sometimes sum of the number of ligand molecules, neutral molecules of ligand, and number of ions. I will give both type of examples here. One example is neutral molecules of ligand. Here you can have this cobalt hexamide. In this case, there are 6 ammonia molecules which are attached to one cobalt ion, or cobalt is one ion. Okay, but it can accept 6 into 1, 6 pairs of electron from 6 ammonia molecule. Each ammonia molecule will donate 1 pair of electron. And ammonia is a neutral molecule. But what happens here? Sometimes, look here, in this case, there are 3 different ligands. 3 different ligands. One is ammonia, another is H2O, water, and the third is Cl. Why? Because as I told you here, that cobalt can accept 6 pairs of electrons, and here only 4 ammonia molecules are there, so they can donate only 4 electron pairs. So 2 more electron pairs it can accept. So it will accept 1 electron pair from water, the other from chloride. So here chloride is anion and these two are neutral molecules. Therefore, sometimes a negative ion can donate, or sometimes a neutral molecule or sometimes both neutral molecule and anion can donate the pair of electrons. Now, this these number of pairs of electrons are called coordination number. So, in this case, silver ion accept two pairs of electrons from two molecules of ammonia. Therefore, this is called coordination number of central metal ion silver. So, the coordination number of silver is 2. If you take this example, here copper can accept 4 pair of electrons. So, totally 4. This is called coordination number of copper. Similarly, here in this case, cobalt can accept 6 pairs of electrons. Therefore, 6 is the coordination number of cobalt. And in the case of these atoms, they lose different number of electrons. Here we have seen that cobalt can lose 3 electrons, but silver can lose only 1 electron, and copper can lose 2 electrons. Therefore, this number is called oxidation number. So the number of electrons lost by the central metal atom to convert itself into central metal ion is called oxidation number of that metal atom. So here the oxidation number of silver is 1 because it is losing, therefore plus 1. For copper it is plus 2 and cobalt it is plus 3. Now how to calculate oxidation number if we don't know? Here cobalt, the oxidation number we don't know, let's take it as X. Here ammonia molecules are 4 in number, that means 4 molecules are there. Water 1 molecule, chlorine 1 anion. The oxidation number here is 0. Why? Because both ammonia and water is in molecular form or they are in neutral molecules. Therefore, the charge on a neutral molecule will be 0. So, charge on molecule is 0. Therefore, we have taken here oxidation number of ammonia as 0. Similarly, for water, it is 0. But how many number of atoms or molecules are there? 4 ammonia molecules, 1 water molecule. And if you can come to anion, only 1 chloride atom is there, but chloride will be having negative charge. So the oxidation number of chloride is -1. So as I told you just now, the total charge on molecule will be 0, but on ion it will be equal to the charge present on that species or cation or anion. So the total should be equal to this number, which is +2. So you can convert this into an equation x plus 4 into 0 plus 1 into 0 plus 1 into -1. So it is x plus 0 plus 0 minus 1. So it will be x minus 1 and it will be equal to +2. Now send this -1 to right side, you will get x is equal to +3. Hence, the oxidation number of cobalt in this species is +3. As I have stated here, cobalt can lose 3 electrons, therefore its oxidation number is +3. Later on you will learn that this is also called as primary valency of the central metal ion. So the oxidation number is also called as primary valency in complexes. Next is complex ion. If you try to know about the complex ion, you have to take it again. The same example you can take. This total is called complex ion. Okay, it is complex ion. Why it is complex? Because it is not a simple. In simple cation, there will be only one ion like Na plus or Cu2 plus or CO3 plus. Here it is a combination of two or more species, therefore it is called complex. And it will be having coordinate bonds between them, or they will form coordinate bond with this atom, and also this will not ionize in the water. So this is non-ionizable. Okay. So the complex ion is an electrically charged or neutral species. Sometimes it will be neutral or sometimes electrically charged. Now, when we say electrically charged, the charge can be either positive or a negative. So there are three possibilities. One is negatively charged, that is anionic form, or positively charged, that is complex ion, maybe in cationic form, or if it is having no charge or neutral species, then it will be neutral one. So there are three types of complex ions. Now, what is that? Actually, it is a combination of central metal ion and one or more ligand molecules. Central metal ion and one or more, means here three ligand molecules are there. So again, we can take other examples. This is another complex ion, one more complex ion like that. Now this is also a complex ion in which copper is central metal ion, and these are four chlorides. Actually, one chloride will have one negative charge. Four chlorides will have four negative charge. Out of four here, -2 is even. Why? Because of four, two will be neutralized by two positive charges of copper. So we can say copper exists in +2 form. Or in other words, copper has +2 oxidation state here, or the primary valency of copper is 2. We can say in different statements. Here, the total charge on the complex ion is -2, means it is an anion or it is in anionic form. Again, similar anionic form for another ion, COCl4 take with two negative charges. Again, four chloride ions are there, means four negative charges. Of these two are neutralized by two positive charges of cobalt, and therefore the -2 charge on the complex ion. Let us take another example. There we have negative charge. Here we have positive charge, and here in this case nickel tetracarbonyl. Here from this NiCO taken 4 times means nickel tetracarbonyl has 0 charge. So this one is anionic, this one is cationic, this is the neutral. So here we have cationic form. Okay, cationic form in which this is complex ion, this is called central metal ion, and this has +3 charges. Why? Because you remember that cobalt can form tripositive ion in first stage by losing 3 electrons. Here the ligands are neutral. What is ligand? ammonia molecule, 6 ammonia molecule, all are neutral. They are giving 6 electron pairs to form 6 coordinate bonds with cobalt. But they have no negative charge or positive charge, negative charge here. Therefore, the total charge on the complex ion will be equal to the charge on central metal ion, or the charge of complex ion will be equal to oxidation state of the central metal ion. Central metal ion has got 3 positive charges, therefore complex ion also will be having 3 positive charges. The coordination sphere. This in total is called coordination sphere. To understand that, we will take example, but before that, what is the definition? The central metal atom or ion and the ligands which are directly attached to it is called coordination sphere. And we have to remember that it is non-ionizable in water or in any solvent, to which it is added. So when a coordination compound is added to water, this coordination sphere will not get ionized. It exists as a unit in that solution. This is called coordination sphere. So generally, we write the coordination sphere in square bracket. This is the reason why this has a square bracket. Again, this has a square bracket and so on. So you please remember that all the spaces which are written inside the square bracket, whether they are enclosed in small bracket or not, both these are included in coordination sphere. So coordination sphere has a central metal ion and ligands, or ligand molecules or ions, and ligands may be one or more than one. So this CO here is called central metal ion, and NH3 here is called ligand, and there are 6 ligand molecules. Therefore, 6 is called coordination number. Okay, and this is the charge on the ion. It is a positively charged ion. Therefore, 3 positive charges are it is in cationic form. Now, here also we have similar situation. This is called coordination sphere. Actually, there will be 3 negative charges if ammonia molecules are 6 in number, but only 4 are there. Therefore, to satisfy this, the valency, or that is called secondary valency, later on we will learn that also. So to satisfy that, 2 chloride ions will come inside, means they will act as ligand. So the total number of molecules of ligand are molecules plus anions will be 4 plus 2, 6. Again, the coordination number of cobalt will be 6. So the spaces which are enclosed in square bracket are called coordination sphere. This is the charge on it, and this is the charge on it. This is called ligand. This is called central metal ion, and this is called coordination number. And you should remember that this ligand is satisfying the secondary valency of cobalt with 6 molecules. But if it has less than 6 molecules, like 5 or 4 or 3, then the anions which will be there in solution with this will come inside, so that they also act as ligands, so that they complete their or satisfy their secondary valencies. In other words, cobalt has coordination number as 6. Why? Because it can accept 6 pairs of electron from the ligand. So the coordination number of cobalt is here 6. Why? Because it can accept 6 pairs of electrons. So this is about few topics in today's lesson. Actually, it is a lengthy lesson, so it is not the end of the lesson, but we have to stop here due to time constraints, and we will continue the same lesson in second part, or there may be at least 4 parts for this lesson. So we will meet in second part or part 2. So let us end here. Thank you, one and all.